So next on this series on inspection and testing of electrical machines or electrical equipment, we are going to be looking at the power transformers. Power transformers. So basically, as usual, we are going to be looking at two different sets of inspection and testing. So the first is the visual or mechanical inspection and testing that has to do with the physical aspect of the asset. And then the second will be the electrical test on the equipment. So all of these are meant to actually look at the physical and electrical integrity of the transformer. What we are going to be doing under the visual or mechanical inspection is to look at the physical integrity of the equipment to ascertain that there are no dents, there are no external damages on the transformers. So look at the bushings if there are physical signs of cracks. Look at the fins if they will have a dent or signs of leakage. Look at the anchorage to see that, especially those that have been installed, see that we do not have any loose ends. Okay, so we are going to look at this in a little more details. So during the if it's a new transformer that is newly brought to our facility, we want to look at the impact recorder. We can do that before it is unloaded while it is still on the flat bed. Okay, so this is the impact recorder. We download the information from the impact recorder before we drop the transformer. So this is actually to ascertain the degree of impact during shipping and transportation. So if we see that the light here is flashing, okay, it's not enough for us to refuse the shipment. We need to analyze the information to ascertain the degree of impact, as we said earlier. If the degree of impact is within tolerable level, of course, we can accept the transformer. Once it is flashing like that, we just make the notation on the delivery receipt and inspect the transformer if there are any visible signs of damage. So if damage actually happen that is very severe and clearly visible, then we can leave the item in its original package and request immediate inspection from the delivery company so that the actual impact, okay, the degree of impact will be ascertained and confirmed by everyone. So this is what you will see on your during your analysis. So the degree of impact, that is the amplitude of the impact and the time of occurrence, all of them will be recorded. We'll analyze it to see if none of them is beyond the alarm limit. So we'll go ahead to look at the nameplate information to verify that what was actually specified and ordered, okay, is what is delivered. So this we can also do on transformer that has been installed already. We'll look at that transformer, look at the nameplate, and then try to also ascertain that what is specified is actually what is installed in the unit. So basically what we'll do, we'll look at the input voltage, that is the high voltage side, then the output voltage. Okay, this is the output voltage, the input voltage and the output voltage. So if it matches what was requested, fine. And then the power rating. Okay, so the power rating, those are some of the things that we look at. For the ambient temperature, which indicates the maximum temperature of the environment in which the equipment, the transformer, can operate. So we look at it if it actually matches the ambient temperature that's expected in the area where we are installing the transformer in our facility. So all of those we are to check and see that it actually meets specification. So we can also look, especially those that has been installed already, we can look at our drawings, okay, to see that the nameplate information actually matches the section to which that transformer is installed. So as you can see here, we have the extra high voltage. Then all of these areas, these are 11 kV, which means that the input to this transformer will be 11 kV and the output expected is 3.3 kV. So all of these should be clearly seen on the nameplate. So after verification of all of this, it therefore means that the unit meets the specification that we require for our facility. So still on the physical inspection, we'll check the dew point of the tank gases. Okay, so we check the dew point of the tank gases to be sure that we do not have gases that will condense at the temperature, at operating temperatures. So that is also very important. Okay, so we inspect all the anchorage, check the alignment and the grounding for those that have been installed to see that there are no defects. Of course, we can retorque them to see that they are actually properly made or tight enough. Then the bushings, we want to see that the bushings are clean. There are no dents in them. Dents have a way of reducing the insulating integrity of the bushing. Okay, the dents can conduct better than the insulating material used for producing the bushing. So we want to ensure that it is dirt free and it is clean of any dirt. So those indicating devices like the temperature and the level, pressure indicating devices, okay, we want to check them to see that the range of the readings, they match the range that we are expecting in our facility, and also the settings, okay, the alarm settings and the trip settings, they actually match what we are expecting or they are specified. Are we getting it? We want to be sure that they are specified for the operations of that particular transformer in our facility. So you look at it and then ascertain that this unit will actually give us the alarm or will actually cause the tripping that we need when the condition of operation goes beyond that level. So that is very important also. So these are some of the trip device. This one is actually indicating the oil level. Okay, both oil level are also measured. So the cooling fans, as the transformer gets bigger, we need an effective cooling system. You can look at the description below for the link to our earlier training on transformer cooling system. Okay, so for larger transformers, we actually need the fan to help force air onto the fins of the transformer to help remove heat. So this heat, as they are removed, if it is very effective, that will help to prolong the life of the transformer. So we want to look at the cooling fans to be sure that they are operating appropriately. The direction of rotation is the right direction that will force air to the direction we want the air to be forced. If it is to remove air, okay, that is to create vacuum within the transformer fins, you should be able to that is extract air from it from the transformer or blow air to the transformer, we want to be sure that the blade is actually in the right direction. So we also want to check the nameplate on the fan, okay, the cooling fan. Look at the full load current and see that an appropriate protection device is installed, okay, installed on that particular cooling fan, such that when the fan fails, the alarm signal, the next signal will be sent to the control room, to the control operator, for the control operator to take the necessary action. Or if that fan can affect the cooling system drastically, of course, that should initiate a shutdown of the transformer. So we want to check that the appropriate protection, overcurrent protection system is on it and they are working properly. So we want to also inspect all the bolted electrical connections for signs of high resistance. So those high resistance points, of course, we'll see the discoloration or deposits of metal oxides, those whitish substances or greenish substances. So if those ones are visible on those connection points, okay, those terminals, of course, we want to take the necessary action, clean and tighten properly. So we can also use the low resistance ohmmeter to check the level of resistance at those connection points. Then the level of liquid in the tank and in the bushing, if it is the liquid fill oil filled bushings that is used on the transformers. So we want to check that we have the appropriate levels in those pieces of equipment. So the pressure switch and okay, we also want to ascertain that the blanket gas in the transformer, we have enough in it that to maintain the positive pressure. Okay, so we want to verify that positive pressure is maintained on the gas blanket transformers. We want to verify the presence of the surge arrestor. We want to look and be sure that we have surge arresters, okay, on the transformer. So the tap changers, we want to look at the position at which the tap changer is left, if it is actually at the specified position, okay. So if it's at the specified position, of course, if not, we need to do the necessary adjustment.